Okay, so this little lesson here, we're going to factor polynomials. We factored polynomials before when we did quadratics, but more generally, higher order polynomials with degrees of 3, 4, 5, and such. How to factor these. Keep in mind, factoring just means to write as a product, okay? And when we're factoring, what we want to do is we want to factor completely, all right? So, okay, so factor completely. And what that's really going to mean is that we write as a product, okay? Write as a product where each factor, right? Okay, so write as a product where each factor can't be factored anymore, we'll just say, okay? Like we do with numbers, right? So if we take 24 and we say factor this completely, well, we might first say, all right, well, this is 6 times 4, okay? And we're not done factoring here because, well, 6 and 4, you could still factor more, right? 2 times 2. 2 times 3. And then we look at here, we have these 4 factors. And since each one can't be factored anymore, in this case, they're prime, okay? Then we know that this is factored completely, okay? So it's 2 times 3 times 2 times 2. Okay, so very similar here when we're factoring polynomials. All right, so let's look at a couple examples here of what we mean by that. So in this case, we're going to factor all these, right? Factor, find the individual factors that make up when you multiply this polynomial. X cubed minus 7x squared plus 10x, okay? And when you're doing this, there's going to be a couple different things we're looking for. We want to look for monomials, right? You always want to really start with a monomial factor, right? Look for any monomials. Difference of squares, right? A squared minus b squared for now. And there's going to build up more. You're going to be just looking for your MF doctor stuff. Okay, so factoring quadratics. Okay, and there's going to be some other patterns and stuff we add on to this, but this is what we're thinking. So if I look at this one here and say, okay, what am I factoring out of this? Well, you look and say x cubed, 7x squared, 10x. There's a common factor of x, so I take that out. What's left? X squared minus 7x plus 10. And now every stage of the game, right? Now here's our little factor tree. We have, I'll put it in parentheses, there's my two factors, x and this quadratic here. And every time you factor, you want to ask yourself, can this factor any more x? No. What about this? When you look at this as a quadratic and we say, all right, well, factors of 10 add up to 7. Yep. Factors of 10 add up to 7. That's going to factor. All right, 5 and 2. So now if I did a little, factor tree, I'd have x here. And now I branch off into these two factors here. Okay, you don't have to write this factor tree as we move forward, but just to see it's similar to numerical factoring. And what we have here is x, 5, x2. Signs are the same because of the plus and minus and minus. And now when we look at x times x minus 5 times x minus 2, we have 3 factors. If I look at each one of those, I can't factor them anymore, in which case that means that I have factored my original polynomial completely, and there's my final answer, factored, okay? So there's that one. Let's look at another one here. Let's go with 2. We're going to factor 3n to the 7th minus 75 n to the 5th. And what we're thinking about doing here is common monomial. What's in common with 3n to the 7th and 75n to the 5th? Well, there's a 3 in common and an n to the 5th. We want to take out really the what? This is a monomial, and it's our greatest common factor between those two terms, right? What's the greatest common factor between those? 3n to the 5th. What's left is n squared minus 25. And now, well, 3n to the 5th, that's monomial. That's just going to keep coming along, right? So we can always just keep writing that along. Bring that along for the ride. And now here, what is this? This is a difference of squares. Difference, two perfect squares. So that's going to factor into n plus 5 times n minus 5. And if you look at everything here, we could see that It is all factored. Nothing can break down anymore. Done. Okay. And one more here. 3. We have 8m to the 5th minus 16m to the 4th. And then plus 8m cubed. Okay. And here, what do we have? Common monomial. 8, m to the 5th, m to the 4th, m to the 3rd. So we could take out an 8m cubed. What's left? M squared minus 2m, right? And then here, plus 1, right? And then when we look to see, well, that we know is done, 8m cubed. But what about this? This is a quadratic, and we're going to say factors of 1 that add to 2. All right, it's going to work. 8m cubed, and what do we have? M and 1 works, m and 1. Signs are the same. Same as what? That, minus and minus. Okay, and we are done. Doesn't factor anymore, doesn't factor anymore, doesn't factor anymore. We could see here also at this point, since both of those factors are the same, what that means as this right here must have been a perfect square trinomial. Okay, but we don't have to write it as such. You know, this would be the same as writing this. All right, they're equivalent, but in either case, they are factored completely. Okay, so there we have our factors. All right, so that's, you know, factoring completely the things we're looking for and what we want to do. Okay, when we're factoring completely, look for a monomial, and after every factorization, check to see if any factor can be broken down more. Okay, so watch this one over, take some notes on it. Let me know if you have any questions.